Hello student, in this video we will study about CBSE 9th grade physics chapter gravitation. So in this chapter the topics which we are going to cover is universal law of gravitation, free fall, mass and weight, thrust and pressure and buoyancy. It's a complete video for the gravitation chapter. So first we will start with the introduction of this chapter. In introduction, we will study about the force. Force and laws of motion is a part of your syllabus. So I already made a video based on this topic. You can check it out. Link is given here. Force is needed to change the speed or the direction of the motion of the body. So here we will understand this with few examples. So in example 1, you see we have a body and this body initial speed is 2 meter per second and it's a straight road, so there is no change in direction takes place. After reaching the point B, final velocity becomes 4 meter per second. So here definitely we applied certain force on the body, so the speed of the body changed when it reaches to point B. Similarly, if we take another example, in this example you see this is a circular road, here is a road and here is a car. So this car are moving on this circular path. So we assume that the speed of the car is constant, but each and every point its direction is changing. If the car is at this point, assume at A, if the car reaches at point B, here direction is different. If it is point C, here direction is different. So each and every point, the direction of the motion of the car is changing, but its speed is constant. This type of motion is called as uniform circular motion. So there are many types of forces acting on the body. It could be normal force, friction force, spring force, gravitational force, magnetic force. Many forces are there. But here for this chapter, our focus will be on the gravitational force. So to better understanding of a gravitational force, we have to know about the centripetal force. Centripetal force is defined as a force that acts on a body moving in a circular path and is directed towards the center around which the body is moving. Let's take an example for understanding this centripetal force. Here we took a body and this body is moving with a constant speed. U is represented as a speed and it is constant. When there is no force acting on a body and body is moving with a constant speed, so body will move straight without change in direction. Now here you see I applied a force F which is perpendicular to the direction of the motion of a body. So here F is force is perpendicular to the speed. So when we apply the force which is perpendicular to the speed, the direction of the body will change. Initially it was moving straight, but when we apply the force, then the direction of the motion of the body will change. Suppose here we applied only one force on this body, then its direction changed. If we have continuously applied the force on the body, so what will happen? Let's see here. In this figure, you see we took few points. You can assume as this as A, B, C and D. At A, body was moving with a constant speed U and we apply a perpendicular force F. So then the direction of the body will change. It will start moving in this. Again we apply certain force. So continuously forces is acting on the body and due to the force acting on the body, direction of the motion of the body will continuously change. So at A, it is moving in this direction, then B again it changes, C and D. So it doesn't mean that force we are acting only at A, B, C, D. It is only for reference. Force is continuously acting each and every point of the body. So due to that, circular motion takes place. The body moves in a circular motion. So when circular motion is possible? When force is continuously acting on the body and force must be perpendicular to the speed. Second thing you notice, the direction of the force is towards the center. If you join all the forces like this forces, if I make like this, here at B, again with C and D. So if we have continuous force acting on the body, all the forces will meet at the center. So this force is called as centripetal force. So I hope you understood this part completely. Now, this centripetal force are of many types. Gravitational force is also example of centripetal force. So now we will start our first topic, universal law of gravitation. Hello student, Anand Academy providing CBSE and ICSE board classes from 6th to 12th grade. And we are taking maths, physics and chemistry classes. Mode is both online and offline. Our center is now in Bangalore. So if you want to know more, you can visit anand.academy or you can call on this number. In universal law of gravitation, we will study about the gravitational force and we derived the formula of a gravitational force. Gravitational force is defined as an attractive force between the two bodies. It is a non-contact force and it is derived by Newton. If we take example, here is a two body A and B. Body A has a small m mass and body B has capital M mass. So body A attracts body B with a force of Fa and body B will attract the body A with a force of Fb. So based on Newton's third law, Fa will be equal to Fb. Newton's third law is the universal law. It says that every action there is equal and opposite reaction. So if body A will attract body B, so body B will also attract body A. So now we will derive the gravitational force formula with the help of universal law of gravitation. Universal law of gravitation says that every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. And the force is along the line acting the center of the two bodies. Let's understand this definition. So here you see we have a two masses A and B. A has a small mass m, B has capital M. So according to the universal law of gravitation, gravitational force is directly proportional to the product of their masses. It means that it is directly proportional to the small m into capital M. A small m and capital M are the product of the two masses and inversely proportional to the square of the distance between them. If the distance between the both the masses is a small d, so F is proportional to the product of the masses and F is inversely proportional to the square of the distance between them. So if we combine it, F is proportional to small m capital M by d square. So by this way we can derive the universal law of gravitation. So let's start the derivation part. So we know that gravitational force is directly proportional to the product of the two masses. So if we have two body A and B, A's mass is a small m and B mass is capital M. So gravitational force is directly proportional. This is the symbol of directly proportional to the product of the mass of the body. So here F is proportional to a small m into capital M. So it means that when the mass of the body will increase, so force will also increase. And when the product of the mass of the body will decrease, so force will decrease. Suppose initially a small m was 1 kg and capital M was 10 kg. Now if the mass changed to 0.5 kg and this becomes 5 kg, so mass is now reduced. So in this case, force will reduce. So more the product of the masses, more the force of attraction. Like you see, Earth and the Sun, they are very huge body, huge mass. So their force of attraction is very high. So that's why Sun and Earth, they are very far from each other. But force of attraction is acting between them. But if you take two small bodies, so their force of attraction is very less. So this relation we consider as relation number 1. Similarly, gravitational force is inversely proportional to the square of the distance between the two bodies. If we have two body A and B and the distance between the two bodies is small d, So gravitational force is inversely proportional to the square of the distance between the two bodies. Inversely proportional we always write with reciprocal like 1 by A, like that. So this represents inversely proportional. So here force is inversely proportional to distance square. This is our relation number 2. So from relation 1 and 2, F is proportional to the product of the mass and inversely proportional to the square of the distance between them. So when we remove this proportionality to the equal to sign, we have to substitute a constant. So why we need to remove the proportionality to equal? Because proportionality only give the relation, means how the force will increase or decrease, but it will not give the value, means we can't solve the problems based on proportionality. We always use a constant. So that's why when we remove the proportionality to equal sign, we always use a constant. And here this constant is capital G. This capital G is called as universal gravitational constant. And because it is a constant, so it must have a fixed value. So here capital G is equal to 6.673 into 10 to the power minus 11 Newton meter square per kg square. For better calculation, we can also write it as 6.67 into 10 to the power minus 11. That's also fine. Now, we already know that force SI unit is Newton. But how to derive the SI unit of capital G? Here it is already mentioned, it is Newton meter square per kg square, but how we got it? Let's look into it. To find the SI unit of capital G, we know that force is equal to G m1 m2 by d square, and if we reciprocate it, capital G is equal to F into d square divided by a small m into capital M. Force SI unit is Newton. It's represented as capital N. Distance SI unit is meter. So distance square is meter square. Mass is kg. So we have product of masses. So it is kg into kg. So after we multiplying kg into kg to become kg square, meter square and Newton. So G is equal to Newton meter square per kg square. Now we will solve one question based on this formula. In this question, find the gravitational force between the Sun and the Earth. The mass of the Sun is 2 into 10 to the power 30 kg and the mass of the Earth is 6 into 10 to the power 24 kg. The distance between the Sun and the Earth is 1.5 into 10 to the power 11 meter. So here I noted down the given values. Mass of Sun is 2 into 10 to the power 30 kg. Mass of the Earth is 6 into 10 to the power 24 kg. The distance between the Earth and the Sun is 1.5 into 10 to the power 11 meter. So by applying the law of gravitation, we know that F is equal to G me into ms by d square. So G value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Mass of Earth is 6 into 10 to the power 24 kg. Mass of Sun is 2 into 10 to the power 30 and the distance is 1.5 into 10 to the power 11 whole square. So after that, I removed the powers first. So this is 10 to the power minus 11, 10 to the power 24 and this is 10 to the power 30. So minus 11 plus 24 is 13 and 13 plus 30 is 43. Similarly, denominator is 1.5 into 1.5 and 11 into 2 is 22 because it's a square. So after this, 10 to the power 43 and 10 to the power 22, if we subtract, we will get 10 to the power 21. So 6.67 into 6 into 2 divided by 1.5 into 1.5 into 10 to the power 21. Further, if we solve it, I can remove the decimal from this side and this side. So it is 667 into 12, 6 2 is 12 divided by 15 into 15. Further solving we will get 35.6 into 10 to the power 21. It can be also written as 3.56 into 10 to the power 22 Newton. So this is the answer for this question. Now we'll start our next topic, free fall. Free fall is defined as when an object falls under the effect of only gravitational force towards the earth, it is said to be the free fall. In this figure, this is earth and here is the object. So we know that based on law of gravitation, earth will attract this object towards the center. So on this object, only gravitational force is acting. So this is considered as a free fall. But when we throw any ball upward, it means away from the surface of the earth. So it is not considered as free fall. Why? Because we are applying a force on the body. So this force is not a gravitational force. So it is not considered as a free fall. I hope you understood this part properly. And you see the direction of the object is towards the center of the earth. So that's why the direction of the motion of the object does not change during free fall. And in free fall, the velocity of the object changes. Initially, the object was at rest, but due to gravitational force, its speed has started increasing. And when it about to reach the surface, it has maximum speed. For better understanding, now we'll study about the acceleration due to gravity. Acceleration due to gravity is defined as the acceleration with which a body falls towards the earth due to the earth gravitational pull is known as acceleration due to gravity. It is denoted as a small g. So we know that Newton's second law says that force is directly proportional to the mass into acceleration. So F is equal to m into a. So when we are talking about gravitational force, so this force will change to the gravitational force. So the acceleration will change to the acceleration due to gravity. So gravitational force can be written as m into a small g. Both are acceleration, but because of the change of the force, we change the acceleration to acceleration due to gravity. But their unit is same. Their properties are same. So here acceleration due to gravity SI unit is same as acceleration, it's meter per second square. Now we will study about the relation between a small g and the capital G, means acceleration due to gravity and universal gravitational constant. In relation between a small g and capital G, we know that from the law of gravitation, gravitational force is equal to capital G, a small m, capital M by d square. And from the Newton's second law, force is equal to m into g. This is the earth and here is the object. So this object has a small m and the earth has capital M. So we consider the object is present on the surface. So the distance between earth's center and the body is small d. So from relation first and second, we can say that a small m into g, which is the force, is equal to capital G, a small m, capital M by d square. A small m gets cancelled. So a small g is equal to capital G, capital M by d square. So this is the relation between a small g and capital G. Let's see how to calculate the value of a small g on Earth. So for this we need to know the mass of Earth, because here capital G is the mass of Earth. Its value is 6 into 10 to the power 24 kg. Radius of Earth is 6.4 into 10 to the power 6 meter. Why we are using radius of Earth as d? Because here we are finding the acceleration due to gravity on the surface. So when we consider acceleration due to gravity on the surface, our distance is the radius. So after applying the formula, small g is equal to capital G into capital M by d square. Capital G is 6.67 into 10 to the power minus 11. Capital M is 6 into 10 to the power 24. And the radius of Earth is 6.4 into 10 to the power 6 meter. The radius of Earth is in kilometer is 6400 kilometer. But our SI unit of the distance is meter, so we convert it to meter. Then after solving, 6.67 into 6 and 10 to the power minus 11 will be subtracted with 10 to the power 24, so it is 10 to the power 13 divided by 6.4 into 6.4 into 10 to the power 12. 10 to the power 12 we got it because it's a square here. After solving further, we remove this decimal from numerator and denominator. we will get it as 667 into 6 into 10 to the power 13 divided by 64 into 64 into 10 to the power 12. So if you subtract the exponents, it is 10 to the power 1. And after solving 667 into 6 by 64 into 64, it will come as 9.8 meter per second square. So this is the acceleration due to gravity on Earth value. So this value we have to remember it. Sometimes round it off. We can also write it as 10 meter per second square. When we have to use 10 meter per second square, when it is given in the question that you choose small g as 10 meter per second square. But if nothing is given, then we always take 9.8 meter per second square. Now we will study about the motion of objects under the influence of gravitational force of the earth. So in chapter motion, we studied about the equation of uniform acceleration, where we remembered three formulas: v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. Here v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. If we convert or if we change this formula with respect to acceleration due to gravity, so the a will change to g, because under gravitational force, acceleration is equal to acceleration due to gravity. So you see the new formula is v is equal to u plus gt, s is equal to ut plus half gt square, and v square is equal to u square plus 2gs. So all these three formulas, when we will apply, when we will solving the question based on gravitational force, and the motion direction is equal to the direction of the gravitational force. Let's take example. Here I took two example 1 and example 2. In example 1, the body is placed at certain height h and the body is dropped. So you see, when the body is dropped, the motion of the body is in the downward direction, and the acceleration due to gravity, it's always on the downward direction. So both motion and the acceleration due to gravity acts on the same direction. So in this case, v is equal to u plus gt, s is equal to ut plus half gt square, and v square is equal to u square plus 2gs. In the second example, the motion of the body is on the upward direction because the body is on the surface and we apply certain force in this direction. So the motion is in the upward direction. And we know that acceleration due to gravity is always on the downward direction. So in this case, the motion of the body and acceleration due to gravity both are in the opposite direction. So that's why in this case, acceleration is equal to negative of g. So v is equal to u minus gt, s is equal to ut minus half gt square, and v square is equal to u square minus 2gs. So according to the motion of the body, the sign of the acceleration due to gravity changes. So we'll solve few questions based on this concept so you can understand this concept properly. Let's try this question. A person takes out a coin from his pocket and drops it from a height of 1.6 meter. With what speed does it strike the ground? Here is a coin, and this coin is dropped from a height of 1.6 meter. Here is the surface. So the motion is in the downward direction. So when the body is dropped, then initial velocity is always 0. So here we have initial velocity known 0. Distance is 1.6 meter, and we know that the acceleration due to gravity is always in the downward direction. So A is equal to g, and its value is 9.8 meter per second square. So here we can write g is equal to 9.8 meter per second square. And we have to find the final velocity. At what velocity it strikes the ground. It means that this ball, suppose it is at point A, when it comes to the point B, which is almost touching the ground, so then what is the velocity at that time? So we can use our formula v square minus u square is equal to 2gs. Why we need to use this formula? Because time is not given, so we can't use V is equal to U plus AT, because here time is required but time is not given. So we can't use this one. Even we can't use S is equal to UT plus half AT square, because time is not given. So we have only V square minus U square is equal to 2GS formula left. So V square is equal to 2 into 9.8 into 1.6. U is 0, so we can remove it. V square is equal to 2 into 98 into 16 by 100. V square is equal to 41.36. So V is equal to root of 31.36. V is equal to 5.6 meter per second. So this is the answer. It means that with this velocity, the body will hit the surface. Let's try one more question. In this question, an object is thrown vertically upward and rises to the height of 10 meter. Calculate first the velocity with which the ball was thrown upward. Second, the time taken by the object to reach the highest point. So according to the question, if this is the surface and here is a ball, so this ball is thrown with certain velocity u, which is not given and we have to find it. This ball will reach to certain height and the height is given as 10 meter. So when the body will reach to the maximum height, in this case v is equal to 0. So final velocity is 0 because the body reached to the maximum height. And here acceleration is in the downward direction. So a is equal to minus g minus 9.8 meter per second square. It is negative because the motion and the acceleration due to gravity direction is opposite. So we can use the formula v square minus u square is equal to minus 2gh. So v square is 0. So minus u square is equal to minus 2 into 9.8 into 10. Minus minus cancelled. U square is equal to 196. U is 14 meter per second. This is the answer of the first part. In the second part, we have to find the time taken by the object to reach the highest point. So we can use V is equal to U minus GT formula. V is 0, U is 14 minus 9.8 into T. So from here, T is equal to 14 divided by 9.8 second. So after solving, T is coming as 1.43 second. This is the answer for the second one. I hope you understood this question properly. Now we will study about the mass and weight. In mass and weight topic, first we will see the properties of the mass. Mass is a property of matter. What is the meaning of property of matter? Around us, any object you see, it is a matter. And if it is a matter, so it must have a mass. If we take any box here, and this box is made up of particles, so each of the particle must have certain mass. So mass is a property of matter. Even in air, small particles are present, dust particles are present, so they have a mass. It doesn't matter whether the magnitude of mass is a smaller or bigger. Like we know that one electron, its mass is 9.1 into 10 to the power minus 1 kg. It's very small. And if you take a mass of a book, we can consider it as a 0.2 kg something. So both is a matter, but the difference is the magnitude of the mass. Next property is it measures the matter. Like I explained previously, if we take a heavier object or if you take a lighter object, through mass we can measure the matter. Suppose this is 2 kg and this mass is 1 kg. So we can measure the matter. Next property is mass, it can't be 0, because every object around us is a matter and matter must have a mass. So mass never be 0. If you take any matter, it must have certain mass. Next is it is a scalar quantity. The scalar quantities are those quantities which has only magnitude but no direction. What is the meaning of this concept? If we consider this as a body A and it has a mass of 1 kg. So if the body is moving in this direction or any direction, its mass doesn't depend upon direction. Its mass is always 1 kg. So from here we can say that mass is a scalar quantity. Next is it can't vary with a change in location. So mass is a property of a matter. If you take a body, if this body has mass of 1 kg and it is present on the earth, same body, if it is present on the moon, mass remains the same. Mass doesn't depend upon the location or position. It is always constant. Whether it is on the first floor of the house or on the 10th floor of the house, both has same mass. Next is SI unit is kilogram. Mass SI unit is kilogram. It is represented as kg. A smaller unit we can also consider gram, milligram, but SI unit is kilogram. Similar way, now we'll study about the weight. Weight, it measures the force of gravity acting on a body. Previously, we studied Newton's second law. It says that F is equal to m into a. And then we studied acceleration will change to the acceleration due to gravity when we are talking about the gravitational force. So this force is called as gravitational force. So this gravitational force is also considered as a weight of a body. So W is equal to m into g. So from here we can say that weight measures the force of gravity acting on the body. Second property is it can be positive, negative or zero. Why it happened? Because weight is a vector quantity. Vector quantity means it has magnitude as well as direction. Let's understand this concept. So as you see in this figure, we took a body A and the direction of the body A is downward direction and it has a certain mass m. Acceleration due to gravity is also in the downward direction. So both are in the same direction. So here weight is equal to m into g. But if we take the same body and this body is going upward direction, it has the same mass m and acceleration due to gravity is downward direction. So here in this case W is equal to m into minus g. So it is equal to minus m into g. So what you notice it here, mass is a scalar quantity. So mass doesn't depend upon direction. But this g, which is acceleration, it is a vector quantity. By changing the direction, its sign will change. So in the first case, the body was going down and acceleration was in the same direction. So in this case, acceleration due to gravity is positive. But in the second case, where the body is going up and acceleration due to gravity is downward direction, so their motions are in opposite direction. So that's why here g is negative. So weight is negative. So we understand here that weight could be positive or negative. Now we'll see how it will become zero. Suppose this object is present in the space. And in a space, there is no gravity. So G is zero. So if we have to find the weight, suppose this mass is m. So m into G, this is the formula of a weight. But in this case, G is zero. Mass never zero because it is a property of matter. So weight we will get it as zero. This is called as weightlessness. So when weightlessness is possible, when acceleration due to gravity is zero. Next is it varies with the change in location. In this figure you see we took earth and the moon and same object is placed on the surface of the earth and the surface of the moon having the same mass m. But acceleration due to gravity is changing. On earth it is small g e and on the moon it is a small g m. So from here, if we have to find the weight of the body on earth, we can say that it is m into ge. And the weight on the moon is m into gm. So this weight will not be equal. Why it is not equal? Because acceleration due to gravity on earth and on moon is changing. Why it is changing? So remember previously we did a formula. Small g is equal to capital G m by d square. So here g is constant, but the mass of the earth and the mass of the moon is different, and their radiuses are also different. So, acceleration due to gravity on earth will not be equal to the acceleration due to gravity on the moon. So, based on this, weight will vary from location to location. I will also explain later how this acceleration due to gravity on earth and moon varies. Next is the SI unit of weight is Newton. So we know that weight is the force. So force SI unit is Newton. So now we have studied about the difference between the weight and the mass. Now we will derive the relation of the weight on earth and on the moon. In relation between weight of an object on earth and moon, we know that law of gravitation says that force is equal to capital G, a small m, capital M by the d square. So here the force, which is a gravitational force, we will convert to the weight of the body on earth. So WE is the weight of the body on earth. So it is equal to capital G, this is the mass of the body, mass of the earth divided by the radius of the earth. Why we took the radius of earth? Because we assume that the body is on the surface. So when the body is at the surface, its distance from the center is radius. Same way, when the body is on the moon, weight is equal to capital G, mass of the body, into mass of the moon divided by the square of the radius of the moon. So here you see mass is not changing because mass doesn't depend upon the location. Mass remains the same. From relation first and second, WE by WM is equal to G M ME by RE square divided by G M mass of the moon divided by a square of the radius of the moon. So here capital G cancelled, a small m cancelled. So WE by WM is equal to ME into R square M divided by MM into RE square. So this is the table. In this table, mass of the moon is given as 7.36 into 10 to the power 22 kg. Radius of the moon is 1.74 into 10 to the power 6 meter. Mass of earth is 6 into 10 to the power 24 kg. Radius of earth is 6.4 into 10 to the power 6 meter. If we substitute the value here, mass of earth is 6 into 10 to the power 24. Radius of the moon is 1.74 into 10 to the power 6 whole square divided by mass of the moon is 7.36 into 10 to the power 22 into radius of the earth is 6.4 into 10 to the power 6 whole square. Here we can write it as 6 into 1.74 into 1.74 because it's a square into 10 to the power 36. How we get 10 to the power 36? Here it is 10 to the power 24 and 10 to the power 6 into 2 is 10 to the power 12. So 10 to the power 24 into 10 to the power 12 is equal to 10 to the power 36. It is divided by 7.36 into 6.4 into 6.4 because it's a square into 10 to the power 34. Same way, this is 10 to the power 22 into 10 to the power 12. It's equal to 10 to the power 34. If we solve it more, we will get it as 6 into 174 into 174 divided by 736 into 64 into 64 into 10 to the power 2. So we remove the decimals. So all decimals will be removed. So after that we get this. And this 10 to the power 36 minus 10 to the power 34 is equal to 10 to the power 2. If we solve it further, we will get it as 6. So WE by WM, its ratio is 6 by 1. So from here we can say that weight on the moon is 1 by 6 of the weight on earth. Suppose any object on earth is 60 Newton. So the weight of the body on moon will become 10 Newton because we have to divide it by 6. But mass will not change, mass remains the same, and it happened because of change of acceleration due to gravity. So we will try few questions based on this concept. Here in this question 1, mass of the object is 10 kg. What is weight on the earth? So we know that W is equal to M into Z. And here mass we consider it as 10 kg. G is equal to 9.8 meter per second square. If we substitute the value, weight on earth is equal to 10 kg into 9.8 meter per second square. So W is equal to 98 Newton. This is the answer. Let's try one more question. In this question, an object weighs 10 Newton when measured on the surface of the earth. What would be its weight when measured on the surface of the moon? So, according to the question, weight on earth is given as 10 Newton. We have to find the weight on the moon. So, Wm is 1 by 6 of We, means weight on the moon is equal to 1 by 6 of the weight on the earth. So, if you substitute the value, it is 10 by 6 Newton. So, it will come as 1.67 Newton. This is the answer. Now we will study about thrust and pressure. In thrust and pressure, first we will understand what is thrust. So thrust is a force acting normally or perpendicular on a surface. Let's understand this is a surface here and we are applying the force on this surface. But when this force is perpendicular on this surface, then this force is said to be thrust. Same way, here you see it's a cubical body or a box. This is the surface, one of the surface of a box. When we apply a force which is perpendicular to the surface, then it is called as thrust. So force and thrust both are same, but thrust is a specific type of force when it is perpendicular to the surface. And the SI unit of the thrust is Newton. Let's study about the pressure. As you see in this figure, this is the surface and we are applying the force on this surface. So when we apply the force, it will cover certain area of the surface. Like this is the area. So pressure is defined as thrust per unit area. Pressure is equal to thrust by area. Let's understand by another example. We have a surface and we apply the thrust on the surface. So the area covered by the applied force body, that area is our capital A. So pressure is equal to thrust by area and its SI unit is Pascal. So how we can define 1 Pascal? 1 Pascal is defined when 1 Newton of force is applied in 1 meter square area. So this relation is called as 1 Pascal. Here it is also mentioned when 1 Newton of thrust is acting on 1 square meter area of a body, then it is defined at 1 Pascal. So pressure is equal to thrust by area. Thrust SI unit is Newton, area SI unit is meter square. So 1 Pascal is equal to 1 Newton by 1 meter square. Let's talk about the factors affecting the pressure. We know that pressure is equal to thrust by area. So pressure definitely depends upon the thrust acting on the body and area of the surface on which force acts. So pressure is directly proportional to the thrust acting on the body. So from here what we can say, higher the thrust, higher the pressure, lower the thrust, lower the pressure. As you see in this figure, this is the pin. If we apply the force on it, so pin will apply the pressure on this surface. So when the force is more, then the pressure will also be more. But here we take the area constant. Second factor is area of the surface on which the force acts. Pressure is inversely proportional to the area of the surface on which the thrust acts. Less the area, more the pressure, more the area, less the pressure. So it's inversely proportional. As you see in this figure, here the area is more and here the area is very less. So when we apply the same force on both the body, more area means lower the force. So in this case, here in this body, pressure is less. But when the area is less, pressure is more. So from there we can say that lower the area, higher the pressure, higher the area, lower the pressure. So based on this concept, animal can walk on the desert. It because of their wide feet. So their wide feet allow the weight of their body to act on a larger surface of land. It reduces the pressure exerted on the land by the camel. Because more the area, less the pressure. So camel feet is wider, so due to that pressure is less. I hope you understood this part completely. Now we will try one question based on this concept. In this question, a block of wood is kept on a tabletop. As you see in this figure here, this is a block of wood. It is kept on a tabletop. The mass of the wooden block is 5 kg. Its mass is 5 kg. And its dimension is 40 centimeter, 20 centimeter and 10 centimeter. Dimension means its length, breadth and height. So find the pressure exerted by the wooden block on the tabletop if it is made to lie on the tabletop with its sides of dimension 20 centimeter into 10 centimeter and 40 centimeter into 20 centimeter. So in this question, we have a same wooden block, but its surface is changing with the tabletop. In the first case, the surface touching the tabletop is 20 centimeter into 10 centimeter. And in the other case, 40 centimeter into 20 centimeter. So we know that when the area will change, the pressure will also change. So we will start with the first condition where the dimension is 20 centimeter into 10 centimeter. So as you see here, mass of the wooden block is 5 kg and the dimension is 40 centimeter, 20 centimeter and 10 centimeter. We will consider the first case where area is 20 centimeter into 10 centimeter. So area is always that dimension which touches the surface. So 20 into 10 is touching the surface. So its total area is 2 into 10 to the power minus 2 meter square. And thrust is equal to weight of the body. Weight is equal to m into z. So m we know it is 5 kg and acceleration due to gravity is 9.8 meter per second square. After solving, thrust is equal to 49 Newton. So we have to find the pressure. So pressure is equal to thrust by area and thrust we got it as 49 Newton and area is 2 into 10 to the power minus 2. So if you solve it, we will get it as pressure as 2450 Pascal. So this is the answer for the first case. Second case we will see now. In the second case, our dimension is 40 into 20. So its area will be 800 centimeters square. It is equal to 8 into 10 to the power minus 2 meters square because SI unit we always consider. And thrust is same. It's 49 Newton because mass is not changing and acceleration due to gravity is constant. So if you use the pressure formula, P is equal to thrust by area. Thrust is 49 Newton. Area is 8 into 10 to the power minus 2. So from there, pressure is equal to 612.5 Pascal. So this is the answer of this question. So what you noticed, when the area is changing, area is increased here. It's 8 into 10 to the power minus 2. Previously it was 2 into 10 to the power minus 2. So pressure now 612.5 Pascal. And if we go to the previous one, where our area was 2 into 10 to the power minus 2. So pressure is 2450 Pascal. So from here we can also say that more the area, less the pressure. Force is constant for both the cases. Now we will start our new topic. It's buoyancy. In buoyancy, first we will study about the buoyant force. It is the upward force exerted on an object wholly or partially immersed in a fluid. Let's understand with example. Here is a container and in this container we fill the fluid and we have an object. So right now object is in air. So this object want to go inside it. So we know that if it is object, it must have a gravitational force acting on it. So due to that we have a weight of a body which we represent it as W naught. So when this object reaches on the surface or somewhere inside the surface, the liquid will oppose this motion, means they will oppose the gravitational force acting on the body and they apply the upward force because every body want to remain stable. When we disturb it due to some external force, they are ready to oppose it. So here, the force applied by the liquid in the upward direction is called as buoyant force. Air also applies the buoyant force. How it applies? If we have any body here and we just drop the body down, so air particles want to oppose that motion. This is called as drag force. So each and every particle want to remain in the stable state. If we disturb that stable state, they oppose that disturbance. So here in fluid, if we have any body wants to go inside the fluid, fluid will apply the upward force to oppose that motion. So this is called as buoyant force. By this figure, you can understand easily the body has a gravitational force which pulls it down, but fluid will oppose that force, so that's why upward force is acting on the body. This is called as upthrust or buoyant force. This phenomenon is called as buoyancy. So you might think that when this upward force or the buoyant force pulls the body upward, then how the body sinks or how the body emerges inside the fluid. So let's understand with a simple figure. In this figure, we have three different conditions or cases where we took in the first figure, we took a cork. Second, we took the wood. And third, here is the iron. The cork is floating on the surface. So what happened? This cork want to go down because of the gravitational force, which is the weight of the body, but upward force is acting on it due to the buoyant force. So when this buoyant force is greater than the gravitational force, then body will float on the surface. Similar condition for the wood. Here again, wood want to go it down, but upward force is acting on it. So buoyant force here again greater than the gravitational force. So these are the condition of floating. When buoyant force is less than the gravitational force, so the object will sink. Iron has more gravitational force than the upward force, which is the buoyant force, so the body will sink in this case. So how we will know when the body will float or when the body will sink? So this upthrust or upward force depends upon the density of an object. Higher the density of the object, then it will sink. Lower the density of the object with respect to the density of the fluid, then it will float. So we can say that the magnitude of buoyant force depends upon the density of the fluid. If an object is more dense than fluid, it will sink when placed in fluid, and if it is less dense than fluid, it will float. So from here we can conclude density of an object is greater than density of the fluid, so it will sink. When the density of an object is less than density of the fluid, it will float. And when the density of the object is equal to density of fluid, it will half submerged. Half submerged means it will not go down, little bit down to the surface of the fluid. In lower grades, you have studied about density, and density is used in this concept. So I will explain this. It is defined as mass per unit volume. So density is equal to mass divided by volume. Its SI unit is mass SI unit is kg and volume is meter cube. So its SI unit is kg per meter cube. We have to remember this formula because it will helpful to solve the problem. Now we'll solve one question for better understanding. In this question, the volume of 50 gram of a substance is 20 centimeter cube. If the density of water is 1 gram per centimeter cube, will the substance float or sink? So we just studied relation between the density of the object and the density of the fluid. So first our work is to find the density of the object, because density of the fluid is already given 1 gram per centimeter cube, and this is the CGS unit. It's not SI unit. CGS unit means centimeter, gram and second. So how to find the density of the object? So according to the question, mass of the object is given as 50 gram and its volume is 20 centimeter cube. So we know that density is equal to mass by volume. If we substitute the value 50 gram divided by 20, so it will come as 2.5 gram per centimeter cube. So this is the density of the object, and density of water is given as 1 gram per centimeter cube. So from here we can say that density of the object is greater than the density of the fluid. So in this case, substance will sink. So by this method, you can easily identify when the substances float or sink. Now we'll study about the Archimedes principle. Archimedes principle says that when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the liquid displaced by it. Let's understand this definition with an experiment. Here you see in this figure, this is a spring balance and here is a stone. When we measure the weight of the stone in air, it's coming as 0.65 Newton. But when we put this stone inside the fluid, or you can consider water, then the weight of the stone becomes 0.50 Newton. So it means that there is a loss of 0.15 Newton. So actually what happened, let's understand. Here when the body is in the air, that time acceleration due to gravity is only acting on it. But when the stone comes inside the fluid or the liquid, then acceleration due to gravity is acting on the body, which is in the downward direction, and upthrust or the buoyant force is acting on the upward direction. So net force or the net weight is here force applied by the gravity minus force applied by the buoyant force. So when we subtract it, we will get the net weight of the body. So here initially the gravitational force was 0.65 and the new weight of the spring balance is 0.5. So it means that buoyant force which is acting on the body is 0.15 Newton. And due to this buoyant force, the weight of the stone decreased. Parallelly, one more thing happened. What is that? See in this figure, initially when a stone was not placed inside the water, so water level was suppose 10 centimeter. When the stone completely immersed inside the water level increased, and suppose this increase is 2 centimeter. So in this volume, whatever the weight of the liquid, that will be the buoyant force acting on the body. If you take from previous example, here buoyant force in the previous example was 0.15 Newton, which is equal to the weight of the water displaced. So based on Archimedes principle, we can say that buoyant force is equal to the weight of fluid displaced. At home, practically you can also do experiment. You can take a glass of water and don't fill completely, just half of the glass is filled, and if you put any stone inside it, you will notice that the water level will increase, and whatever the increase in the water level, that much weight of the water is equal to the buoyant force. Numericals and derivations of the formula, it's out of your scope, so we have to just study about the concept, what is Archimedes principle. Let's see the applications of Archimedes principle. Archimedes principle has many applications. It is used in designing ships and submarine, because ships and submarine, they have to live in the water in the ocean. So based on Archimedes principle, we can calculate the weight of the ship and submarine. Lactometers. Lactometer is an instrument which is used to determine the purity of a sample of milk. It is also used in hydrometers, used for determining density of liquid. So I discussed all the module of this chapter. If you face any problem, you can comment me in the comment box. If you like this video, do share it, subscribe this channel and practice more questions so you become more confident in this chapter. Thank you.